In general, when you think about species that have evolved and have survived for millions of years, they would have found a way of living harmoniously with the environment in which they live and breed and eat, forage, whatever. For example, when we talk about hunters-gatherers versus the modern human, like agricultural human, we often assume that maybe the hunter-gatherers were somehow more in harmony with the nature. They were less uh, they affected the environment much less than we do in terms of how the exploitation was done. But some people disagree with that interpretation as well. It's always interesting to look for species which may be living in a particular latitude band in a particular ecosystem and see whether they actually have a negative impact on climate. We talked about whales and elephants as being very beneficial to the ecosystems in which they live and forage. So here is an example of a moose as a species, which this study argues actually have an impact on climate and the carbon sequestration associated with the vegetation. Let's read the abstract and look at some data. Moose is a large herbivore that can mediate, actually I forgot, here it is. This is the animal. It's fairly big and can get pretty aggressive when they are with the babies, and if you get close they can attack you. They're fairly massive animals, so you would expect they do eat a lot, but they are not as big as elephants, for example. Elephants eat a lot as well. So reading again, moose is a large herbivore that can mediate boreal forest regeneration after timber harvest through selective browsing of tree species. Despite increasing evidence of moose browsing influence on tree growth in early successional forests, climate effects due to changes in carbon sequestration rates and biophysical factors such as albedo remain largely unexplored. So when an animal grazes, it changes the leaf area and the landscape in a way that the albedo changes. Trees have a darker albedo than the open spaces, for example. We used 11 years of data from 44 pair sites of herbivore exclosures within clear-cut forests in Norway to investigate how moose browsing alters above-ground tree biomass and albedo. Exclosures are opposite of enclosures, so some areas are cordoned off where certain species is not allowed to come in, so you can compare regions where the moose are freely grazing versus the regions, the exclosures where they are not grazing, so that you can compare the impacts or you can quantify the impacts. We find a higher total above ground tree biomass, mainly deciduous species, in unbrowsed than browsed forest plots, as moose browsing limited the growth of tree biomass. The effect of moose exclosure on relative tree abundances differed between sites, suggesting that moose browsing has stronger effect on forest structure than composition. Okay, the species composition may not be as important as the forest structure in terms of the distribution of age groups and so on. At the same time, moose increased forest albedo relative to unbrowsed forest, driving biophysical cooling, so they increased the albedo. There's a bunch of kids making a lot of noise outside, but hopefully that's not affecting the recording. When averaged at regional levels, climate effects due to changes in biomass and albedo are of similar magnitude, but contributions can diverge in specific locations. In a region with intensive forestry operations and high moose density, CO2 emissions from moose browsing in post-harvested site can be equal to about 40% of the annual emissions of fossil fuels from that region. Okay, 40% of the annual emissions from fossil fuels is how much CO2 is resulting from moose browsing itself. Cooling effects from increased albedo can offset about 2/3 of this impact. Given its influence on tree growth rates and climate impacts, management of moose browsing density should be integrated into forest management plans to optimize climate change mitigation and forest productivity. So it's surprising that moose, which apparently evolved just a couple of million years ago to about as recently as the end of the last ice age, actually have not such a good harmonious relation with the environment they live in. In terms of plain language summary, moose play a key role in shaping landscape structure and forest composition. For example, moose influence vegetation and soils via foraging, trampling, and nutrient cycling, thereby affecting tree growth rate, community composition, and ecosystem carbon budget. It's estimated that moose alone can browse 10% of the annual harvest volume in Norway. 10% of the annual harvest volume. So they are really big animals eating a lot. Moose also alter landscape cover properties, land cover properties such as surface albedo, i.e. the fraction of reflected solar energy radiation. I think we all know that. There are podcasts I have you can look up. With direct implications for climate. So reduced carbon uptake means you are releasing carbon relatively speaking and creating global warming, but increased albedo means you are cooling and maybe compensating for that reduced carbon uptake. A better knowledge of the interactions of climate forest moose nexus can help the identification of integrated management of forest resources and wild herbivores that maximize climate change mitigation benefits and ecosystem services, including timber value. So some sort of a life cycle analysis would help here. Our study analyzed 11 years of empirical field measurements from 44 post-harvest sites in Norway to study climate impacts from both carbon sequestration and albedo dynamics induced by moose browsing. We found that moose browsing cools the climate by increasing surface albedo and warms the climate by limiting forest carbon sequestration. The two effects tend to compensate for each other, but there are large regional variations. Given the potential effects on both tree growth and climate, moose browsing should be more actively integrated into forest management plans. So how human management of forests and logging the forest for timber interacts with the moose grazing has to be considered together. Just some data here looking at the albedo impact in the exclosures compared to open browsing areas. So you can see that the exclosures have lower albedos in these time scales. 2 years since exclosure, 4 years, 6 years, 8 years, and 10 years. So the albedo is successively reduced by not allowing the moose to browse. So exclosure is got lower albedo than the open browsing area, and this is true for all three sites here with different specific locational impacts. If you look at average climate impacts in terms of carbon and albedo and the net effect for the three sites, you can see that there are some regions where the impact on carbon is quite significant in terms of reduced carbon uptake and vegetation biomass because of moose browsing, but it's negative everywhere, and the albedo is increased in all three sites as well. But the net effect is in terms of CO2 equivalent in kilograms per meter squared, positive in one site and negative in the other sites with large standard deviations, of course. So this is not so much a conclusion on what the net impact is, but to say that their impact is not small, that it must be considered in forest management. In terms of biomass in kilograms per meter squared at the three sites, again browsed versus unbrowsed, you can see that unbrowsed recovers over the years to have a higher biomass, except at this sites it's not as big as at this site. So there are region specificities in the impact of moose browsing as well. So it's a good result. Just in terms of our contrast, I have many podcasts arguing that there are species which are dealing with climate change and global warming, like corals or various other polar bears and so on, which are finding ways to survive or even thrive under global warming. But it's always interesting to see if there are species which have evolved to have some sort of an impact on carbon versus land cover change, so that, you know, to survive on an evolutionary time scale, you think they have to have minimal impact on the environment, otherwise they will weed themselves out, right? They will become extinct because they degraded their own environment, which is what we are worried about now. How much are we changing our environment, and how bad is global warming going to get? Are we going to face extinction risks? There are books like The Sixth Extinction, where we have direct and indirect impact on various species which cannot keep up with either our direct habitat degradation or habitat losses because of our colonization or the warming rates and other changes in land cover, land use. So these are all interesting questions to look at various species. One would think that species which live basically on browsing in a particular environment obviously do not outgrow the resources, so they have some sort of a balance. So it's possible that animals like moose are reducing carbon uptake, but they are compensating, or more than compensating, by increasing albedo and cooling the climate, and have a overall balanced impact on the environment in which they live. Okay, so it's an interesting result that I wanted to include here. Okay.